tangential to the disk with a velocity u. Find the angular velocity of the disk. Oh, question has become when string becomes stout. No, what is the disk? Disk is hinged here. What is this everything? So it is able to understand. This is, I think I'm just showing a diagram like this. And O is a inch. Inch means understood. It can only rotate, no? String is what happen? It's just connected to this particular, and initially string is loose, you can see like. Go back to where do we have come across such numericals? Impulse idea, impulsive string. So to in a after collision we have discussed, no, impulsive tension. There I think we have come across situations of like this. The same ideas we are trying to implement here. As the block starts moving, at one instant the string will become taut, no? The moment it becomes taut, an impulse will act. And similarly, an impulse will also set up. That impulse will set up angular impulse about O, and it will make it to rotate. And similarly, that impulse, what it do? It will make this particular to have momentum. It will change the momentum of this. So finally, what we see is like this is a disk. String becomes taut, no? So I'll show a little bit position like this here. Then impulse is set up. JT. Because of that impulse, it will acquire velocity V. At the same time, this impulse, what it will do? JT into R will set up angular impulse and it will make it to rotate. It's a O is a inch. I think able to understand inch means it can rotate only about O, that one. Fixed about O. Or the disk will rotate about an axis passing through and perpendicular to plane. How to do this problem? Is asking find the angular velocity of the disk. About what point I should conserve angular momentum? About point O. Why about point O only? Because this JT impulse, JT what it does, it will try to also pull the disk. And because of that what happen, there'll be like the inch what happen, there'll be impulse will act here. On what direction? The impulse will act in this direction. I have to show that impulse. Red color, I'll show it. This is the impulse, this one. By the inch on the disk. Why J naught? Because the JT what will happen will try to pull the disk towards right. See, sir, it will make it to rotate. Yes, it will make it to rotate and also it will make it to move. Altogether, two things are there, no? If this is, the disk is free to move, what happens? This JT, what it will do? It will set up angular impulse and also linear impulse. Due to linear impulse, will try to move. So the hinge will not permit, so J naught will act here. Now tell me, can you consider angular momentum about this? No. About this point? No. Or about this point? No. About O only. So I should consider angular momentum about O. So therefore, the idea of hinge is very important because every numerical I was stressing you that hinge, no, the reaction at the hinge. Okay, I think let's get into the calculation part. So LOZ I equal to LOZF. So what is the initial angular momentum? MUR clockwise. Final angular momentum mvr clockwise plus I naught omega clockwise. Now there's a string, so velocity of this point P should be equal to Vp should be equal to V. Why? Because there's a string, no? The string has become tout. Find the angular velocity of that is when the string becomes just tout. We are the moment it has become tout, we are discussing that one. So Vp equal to V. At the same time, what is Vp equal to R omega? So velocity of the point P and velocity of the block should be equal, no? Because the string should be inextensible. So I'll substitute that, I'll get the value. So what is I naught? mr square by 2. Okay, these are objective. Definitely the advanced processors will try to ask, instead of asking something math based, no, they will test students like how good he is. The J naught is what you have to show. Huh? It's a very important. You have to show like this. That's why angular momentum is considered about O. Okay, now there's one very good question. I